Good morning, everyone. Good morning, good afternoon, good evening, everywhere around the world. Today we got a workshop, and I'm joined by Siam, and it's going to be some good stuff. You're going to have some stuff you can try out on your own and see how everything works, and building on the last webinar and stuff that we did. We got a couple of these workshops coming up with you, right, Siam?
Yes,
So
excited.
this is the first one. Welcome to the first one. We got a lot to get through. Let me go ahead and hand it off to Siam, and then I'm going to go hide and answer questions and comments and stuff like that, and then I'll be back at the end. We're doing some demo stuff. So you want to hand it off to you, Siam, and enjoy.
Awesome. Thanks, Mike. So hello, everyone. My name is Siam Pathak, and I'm working as Principal Developer Advocate at Loft Labs. So this particular workshop is the continuation of the SuperStream March multi-tenancy series that we are doing. In the last webinar on the stream, Daniel actually touched upon the crux of multi-tenancy, some of the solutions around multi-tenancy. And today we'll be seeing specifically vCluster and how it helps for seamless Kubernetes multi-tenancy. And also we'll try to understand what shared platform stack means and how you can actually use that with the help of vCluster. So let's get started. Just to recap, the problem should be pretty clear. If you haven't watched the last stream, it's really worth it to watch that particular stream. We'll have all the links, in the description. But yeah, just to recap, the problem is too many Kubernetes clusters. So the problem has moved from I cannot provision a cluster to too many Kubernetes clusters, because over the years the adoption part of Kubernetes has become easier, but the management part is becoming tough, because now everyone wants Kubernetes, everyone uses Kubernetes. There is managed Kubernetes. You get clusters in minutes. You get clusters in on any cloud provider with ease, with a click of a button, just giving the name, number of nodes, and some basic button selection, and then there you go. You get the Kubernetes cluster where you can run it. But now the issue is that the enterprises are creating cluster per team, cluster per environment. And when you get that particular Kubernetes cluster, the Kubernetes cluster is just base, like it's bare bones. It doesn't have anything in it. It doesn't have Argo CD in it. It doesn't have Cert-Manager or Nginx controller or Vault or any of the software tooling, the CNCF ecosystem tooling. So what people do is, on every cluster, every team install Argo CD or Flux or Fleet or whatever their GitHub solution is. They install Cert-Manager or similar tooling for certificates. They install Nginx controller or other similar ingress controllers for the ingress. So the duplication of resources is also a big overhead. So big cost. There are multiple Kubernetes clusters. There's the cost per control plane, because the Kubernetes cluster is obviously costly. And then you have to maintain so many Kubernetes clusters. So these are the problems, which are genuine problems of why we need fewer Kubernetes clusters and why we need to move to a multi-tenant environment. So three important key areas for multi-tenancy is workload isolation. So the main thing that we need is team A, team B. Their workloads are separate from each other. They are able to use the resources in a fair way. Like, if we are not giving everything to team A and just little stuff to team B. So fair use of resources. And tenant autonomy, how we can do everything in an autonomous way, like putting less and less burdens on the admins and create a self-serve kind of stuff. Before we get into how to do it, another thing is the shared platform stack. What shared platform stack means. So let's say there are two teams, team A and team B, and they both have their own Kubernetes clusters. They both have they both have to have Cert-Manager. They both have to have Nginx controller if they want HTTPS TLS certificate exported by an ingress. Now this is the duplication of resources. Now we want a multi-tenant environment, but we also want to reuse some of the components. Like, we do not want the separation to happen, but we install everything over again, because then again it's a duplication of resources, and shared resources is still a problem in multi-tenancy ecosystem as well. And I'll show you how vCluster kind of solves it. But yeah, shared Kubernetes, shared resources is something which is very critical when we talk about multi-tenant Kubernetes cluster, because Think of it as you will be having, instead of 10 separate cluster or 50 or 100 separate clusters, you will be having those as same clusters, like separate virtual clusters on the same physical Kubernetes cluster. So the Kubernetes clusters will be one, and you will be having multiple virtual clusters. I'll explain you what that means. Virtual clusters, but you do not want Nginx controller, Vault, Cert-Manager, all those things to be installed separately everywhere. So there should be some way, some mechanism to reuse the shared resources. So let's say we want multi-tenancy. So now we know the problem, why we need multi-tenancy. Let's go to the solution. Okay, namespace. We have namespace in Kubernetes, and in namespace also we have a lot of things. A lot of Kubernetes objects are namespace scope. So let's try to understand that in a bit more deep dive way. So let's say you want security for your workload. So you have the pod security levels that you can enforce. You can do the auditing. You can enforce the policies using OPA, Kyverno, Chase policy. You can have runtime security using Falco. So all these things you can do, and you can do them on the namespace ecosystem. Then you can have something which is also namespace scoped, is you want to restrict. So the one key component that I'm just talking again and again is we want multi-tenant environment, but we do not want workloads in team A to be able to communicate with workloads in team B, and vice versa. And same for all the other teams that we might be doing. So there is the concept, native concept of network policy in the Kubernetes ecosystem, which lets you play with the traffic. So for example, this particular screenshot that you're seeing on the screen, it's basically a network policy where we are saying that for the tenant one, we are only allowing the egress to everything except the internal IPs, and this cover a wide variety of internal IPs that it is restricting the traffic, because we do not want internal traffic from the internal traffic light. And then namespace selector, we want the traffic to go and route internally, at least within that particular namespace. So we allow that as well. DNS port 53, allow that as well. We might also want Kube API server, like it should be able to at least communicate with the API server of Kubernetes. So we allow that as well. So like this, you can configure, like this is a sample one, but you can configure much complex one based on your tenants realm. So that is one. Then you have resource quotas that you can apply on at namespace level. You have limit ranges that you can apply on the namespace level. So what we are saying right now is can we tie namespace to a tenant's realm? So one tenant, one namespace. Tenant two, two namespace. It's easy. You can you do not need to worry about if I named my pod demo and if they named their pod demo in the another namespace, it's fine. They don't have to care. And then we have these kind of isolations on top of that. This is good when you have one or two tenants. It works well, but things start to get complicated when you have multiple namespaces that one tenant wants to use. So how about the number of tenants are getting increased? So there are now 5 tenants, maybe 10 tenants. Every tenant have their own specific requirements of using a few namespaces. How do you calculate the resource quotas? Like let's say tenant A needs 3 namespaces. Okay, you give that 3 namespaces to tenant A, but you define the namespace quota for everyone. And then how do you segregate that? So it becomes a bit difficult. And then how do you distribute those kubeconfig files for tenant A with 3 namespaces, tenant B with 4 namespaces, tenant C with 1 namespace, and so on. So as the number of tenants increase, the number of namespace and the complexity increase, it becomes difficult to use the namespace-based approach. Now this is something which the next part is very critical, because the cluster-wide resources. How do you manage the CRDs? They are cluster-wide resources. What if team A wants Argo CD different version, team B wants Argo CD different version, or they want to test out applications of different versions? How do they do that? The cluster-wide resources. it becomes very difficult. The Kubernetes controllers that people built, how do they test different versions of that on the same Kubernetes cluster? It cannot be done on the namespace based level of multi-tenancy approach. Also, resource sharing still becomes the issue over here when we talk about the shared platform stack. And then different Kubernetes cluster versions, how do you manage that? Let's say there is one who wants to upgrade to 1.32 and one who wants to stay on 1.31. How do you do that? Becomes very difficult. And then there is still a single point of failure, which is a single control plane where it is all running, because it is running on the host cluster, segregated only by the namespace. Every call that every tenant is doing is going to the API server of that host cluster, the simple Kubernetes cluster. So these are the key issues, and this is where vCluster comes in. So yeah, Mike is not here, but Mike has that clapping sounds, you know. So I was thinking he'll do the vCluster clapping sound when I do enter vCluster. Yeah, that one.
Oh, yeah, it goes in.
So enter vCluster. Now, how vCluster? What is vCluster? vCluster is basically an open source solution that lets you create virtual Kubernetes cluster on top of your host Kubernetes cluster. We'll see everything in action very soon. Because I do not want to spend too much time talking, I'll show you so that you understand all the concepts well. So what we have done is, instead of on the left hand side, you are seeing the traditional approach where we have multiple Kubernetes clusters, and we want a multi-tenancy route due to over provisioning, or due to cost control, or due to saving in the number of Kubernetes cluster to a fewer Kubernetes cluster. So now what this means is, on the right hand side you are seeing a single Kubernetes cluster, and now you have on the left on the right hand side Argo CD, you are able to see the logo, Vault, Cert-Manager, Ingress Controller. These are the shared platform stack. What that means is vCluster creates a virtual layer, virtualizes the Kubernetes cluster, and gives you a control plane, isolated control plane. So every vCluster comes with its own control plane, and it runs as a pod, as a stateful set on the Kubernetes cluster. So the control plane is running as a container, running as a pod, and then you are getting the kubeconfig file. You might expose vCluster as a load balancer or ingress, or it just gives you the kubeconfig context that you'll see. And when you switch the context, it's a CNCF certified Kubernetes cluster, conformant cluster. You do kubectl get pods -a, you'll only see the core DNS pod, you'll not see anything else. You won't be able to access the host, you won't be able to access any other virtual cluster. So you just will be able to access and feel that it is your Kubernetes cluster. Think of like you have created an EC2 instance, like and not exact mapping, but similar concept. So you have an EC2 instance that you have spun up, but in the end, you are not you are using the virtualized layer from the bare metal server, right? That's where you are getting that EC2 instance. Similar to that, this is virtualizing the Kubernetes layer and getting you that particular cluster where you feel you are the owner of that particular virtual cluster, Kubernetes cluster, and no one will ever know, like team A or team B or team C will never know that it's not a actual Kubernetes cluster and it's a virtual Kubernetes cluster. As a company wide, you can have your policies enforced, it will be respected by all the virtual cluster. You can have certain tooling mandated like Argo CD or a Cert-Manager, Nginx controller, and that has to be shared across the multiple virtual clusters. That is possible. So vCluster not only virtualizes the cluster, it helps you definitely helps you reduces the number of Kubernetes clusters, but also reuse the shared platform stack, which is a big thing. And now not only the team A can reuse maybe the Nginx controller, they can have their own version of Nginx controller if they want. I mean, they should have the permissions to do that, but it works. All right, I think I'm done, and let's go to the demo time, because workshop is what we are here for. We are here to see how you can do step by step from scratch everything and see this particular thing in action. This particular QR code, just keeping it here for a few seconds so that you can just scan it and go to the GitHub repository so you can try it out. Okay, so this is the workshop. There's the link. I'll also send that to Mike so that he can share that in the comment.
Sounds good. Do you want me here for the demo, or you want I can give you some commentary.
Yeah, so that's the link. That's the repo. The QR code has the repo. This is the link for the. I mean, this is the beautified version. GitHub pages. That's pretty much easier to look. So workshop guide. Let's go to the workshop guide and start working towards it. Now, the prerequisite for that is you need to have a Kubernetes cluster. Now, you can have any Kubernetes cluster. For my case, I already have provisioned the Kubernetes cluster so that I do not waste time over there. So I already have an old Kubernetes cluster, which is up and running. And a few of the things that I have installed is vCluster CLI. So you need to install the vCluster CLI. The current vCluster version is 0.23. Mike and I did a new video on that, which is on the syncing of config maps and secrets. It's a very cool feature. You should try that out as well. Cert-Manager installation and Ingress Controller installation. So till here, everything is done on the cluster that I am having, and I'll show you that. kubectl get pods -a.
Yeah, I just dropped in the chat. It's the link from me right above.
Awesome. So you can see I have Cert-Manager, which is up and running, and you have the Ingress Nginx controller, which is running. Yeah, rest all are the components of the cluster itself, the managed Kubernetes cluster. So that should be fine. Now, what we need to do is we have a small application. So obviously you have an application and you want to deploy that. I am team A. We are talking about team A, team B. Let's say I'm team A. I have my own application. So I have a Go application. What you can do is you can clone that particular repository. You can do Go mod init with your own GitHub username and then Go mod tidy. And I'm building that using Go. So Go is basically a tool to build the Go files, like the Go applications. So you export the code Docker repository as ghcrio and give your own GitHub username, and then the platform. That depends on where you are running. So right now, what my system is Mac M1, but I want to build the image for Linux, because in the end, the nodes where it will be running has to be like Linux. So, and then you do co-build. So we can actually do that. That should be doable. Yep. So co-build app -t latest. So that's a tag. It's building and it will be pushing all the stuff. And then what you need to do is setting up the virtual cluster. So now vCluster list. I told you I have vCluster, but vCluster CLI installed, but I do not have any virtual cluster right now in my Kubernetes clusters created. So I just have the host cluster with Nginx Ingress Controller and Cert-Manager. That's it. Standard basic stuff. Now let's try to see what this is. So vCluster provides you with it's basically a lot of Helm values, Helm chart values that you can turn the knobs on and off for various things. Like, I need resource quota, limit ranges, integrations, like KubeVirt integration, Cert-Manager integration, all those things. Syncer. So there is a concept of sync in vCluster. So what it does is in the architecture of virtual clusters, the syncer component is the one that is responsible for syncing the resources to and from the host. By default, there are obviously the pods, services, the basic stuff that gets synced from the virtual cluster to the host, because in the end, we are reusing the host cluster scheduler so that it copies it from the virtualized SQLite database of the virtual cluster to the etcd of the host cluster. And then as soon as the scheduler sees it, schedules the pod and it runs. Obviously, there are some prefixes and stuff which gets attached, because there are 10 namespaces of a virtual cluster that goes to one namespace of the host cluster, and there are some prefixes attached to that. Anyways, For this particular demo, what we are saying is we want one of the integration to be true, which is the Cert-Manager integration, and we want the sync to host ingress. So we want ingress, any ingress that I create on the virtual cluster to be synced to the host cluster, because I am not installing Nginx controller on my virtual cluster. I want to reuse the ingress controller on the host cluster. Next step is we'll enable the vCluster Pro, because the Cert-Manager integration is like that. If you want to do not in this way, this is the absolute neat way, but we have a kind of deprecated but still works, the generic sync. You can write your own custom generic sync file for the Cert-Manager for the open source one. That should work as well. But to keep it simple, this is the simplest integration, Cert-Manager enabled true. Nothing else you have to do, just 3 lines. And you can use vCluster.cloud. I already have my own vCluster.cloud instance. You can have your own vCluster.cloud instance, and then you can go here in your profile. You can go to access keys, and you can create a access key. So this access key lets you connect to the platform. So we'll do that. vCluster platform login access key. And don't worry, this access key is short-lived. It will be deleted after the webinar, so you won't be able to use it. And just in case. So vCluster platform login done, successfully logged into vCluster.cloud. Now is the time to create the virtual cluster. So let's create our virtual cluster. So vCluster create name of the virtual cluster, and we provided the file that I just show you, which is the integration Cert-Managers and sync to host ingress enabled. So this particular virtual cluster will be created with the specifications that we have given, but there are many things. So if you go to the vCluster documentation, I'm sure Mike is dropping in all the links as I'm speaking. But if you go to the vCluster documentation, and if you see the section of vCluster.yaml file, you will see a long list of stuff that you can do with the customizations for virtual cluster. Now is the interesting part as well. So kubectl get nodes and kubectl config get contexts. So right now we only have 2. My kind one also got merged here. Anyways, what it is doing is it is running a Helm upgrade and doing all that stuff. It is successfully creating up. It is doing a stateful set. Like I said, it is creating up a stateful set, waiting for it to be ready, running a background container, creating a kubeconfig context, and adding that to my kubeconfig. So now I have a separate context within my kubeconfig, which is for the virtual cluster, and it switched automatically to this particular context. So if I now do, so let's say you gave this context to team A, which is me. So now I do kubectl get pods -a. Wow, I have a plain, fresh Kubernetes cluster with me. I don't know if it's a virtual cluster or not. I can do anything. kubectl run nginx -image nginx. I can do everything, and it just runs as the pod should be running on my cluster. I don't care what is happening behind the scenes, and I don't even know if something is happening behind the scenes. Well, I know because I am doing this workshop, but probably to the teams that you will be giving out, they won't know what is happening. So kubectl get pods, you can see it is running as well. Now moving on, so we get we can see in the vCluster list, it should appear in the vCluster list here. Hopefully it should appear in the virtual clusters here as well. Yeah, demo cert is appearing here as well. And then let's move on. We already switched the context. Now configuring the Cert-Manager integration. Obviously, we need an issuer for the Cert-Manager. So there are some stuffs that has to be there. So there has to be an issuer that issues the certificates. There has to be a certificate that we want to issue for a particular DNS. There has to be application deployed. There has to be ingress deployed. So these 4 components now we'll be deploying step by step. First one being the issuer. kubectl apply -f issuer. kubectl get issuer true. Our issuer is there. Now kubectl. So one thing over here is I'll also show you the application and stuff. So app.yaml. This is a simple application. You know, deployment. The image you have to replace, obviously the one that you have built, you have to replace here. Container port is 8080. Simple service for that. Let's also see the ingress. So here it's interesting. So I say I need ingress. Ingress class name is Nginx. Now I need TLS for my host. Here what I have done is I have given cert.vcluster.tech and cert.vcluster.tech, and it goes to the workshop service. Now what happens here is, if I clear the screen, kubectl config get context, and I am now, if you are seeing carefully, I am going to the host cluster. Okay, kubectl config, just to show you the ingress part. Config use context kubectl get svc-a. So what I have is, there is an ingress service which is of load balancer. Now I added the a record to vcluster.tech with this particular load balancer, which is why my ingress configuration of cert.vcluster.tech will work. If you haven't pointed it, then you can use some wildcard stuff, which is nip.io, or I think I have mentioned that over here. Yeah, cert.nip.io or xip.io, stuff like that. So that should work as well, but my ingress would look like this. So don't be in a hurry, because right now I'm in the host cluster context, and all the stuff that I have to create is in the vCluster. So we need to switch back to vCluster context. Let's copy that. Use vCluster. Let's check kubectl get pods -a. Yes, we are in the vCluster context. kubectl get pods -a. Just making sure we're in the right context. Cool. Let's deploy the app. kubectl apply -f app.yaml app. So deployment is getting created and the service. So kubectl get pods. It should be running. It's running 4 seconds ago. Very good. So we created the issuer. We created the app. Where is the app? Now we create the ingress and the certificate. Let's see the certificate as well. So we are saying we want certificate for the DNS name cert.vcluster.com, and this is the secret name. Obviously, the same secret name is also used in ingress as the secret name here. So when you specify TLS, you need to specify the ingress name. So kubectl apply -f ingress, kubectl apply -f certificate. Now it's up to the demo gods to see if it works or not.
I'm ready here with the applause.
Get certificate. One time it will come false for sure. Yeah. So I hope soon it becomes true, or else we have to debug. Okay, it's true. Cool. That is good. Now let's actually check cert.vcluster.tech. Woohoo! Welcome to the Multi-Tenancy March series powered by Loft Labs. Go to loft.sh, and try out vCluster and stuff. It's very interesting. So right now what you just saw is how to use vCluster, not only vCluster, but how to use the integration vCluster YAML file shared platform stack specifically. So right now, if you see, this is my virtual cluster, okay? kubectl get pods -a. I do not have Nginx controller. I do not have Cert-Manager inside my virtual cluster. Now let's switch back to the host cluster.
I think you need a hat to go with when you're on the host cluster versus when you're the user, so that people can tell visually which one you're on.
Yeah, so you can see only here I have the ingress controller and the Cert-Manager components, and this is the one 7 minutes ago, demo cert 0, that was created as the stateful set when I did vCluster create demo cert -f vCluster.yaml and the codens pod. And now these are the pods which I created. So you remember I ran kubectl run nginx -- image nginx. So it prefixed its stuff and it created this particular pod. It also prefixed some stuff here for this, like the namespace and all that stuff is prefixed, and so that it's copied in a different way on the host cluster. And if you see the certificate is here, obviously it will live here. kubectl get certificate -a. So you have the certificate over here, and the secret is again prefixed and revamped on the host cluster when it's synced. kubectl get ing-a will also be there. So you have the vCluster ing, which is cert.vcluster.io. So yeah, that's pretty much it. Definitely, I spent some time in getting those GitHub pages up, so would appreciate if you would try it out and make sure it works. If there are any issues, join the Slack and let us know. This is the QR code to scan that will directly take you to the experiment, but we will put exact this link in the description of this particular stream as well. Thank you. And I hand it over to Mike before I say thank you, to be honest. And
Yeah,
we can now take questions and all that stuff.
Before I talk about this, what are you showing us next time? In 2 weeks?
Oh, yeah. So 2 weeks. So yeah, next one is by Salman. And he'll be talking about standardizing dev environments at scale. And what I'll be showing is how on every pull request, so that will be a complex demo. So on every pull request, how you can actually have a vCluster, have an automated way of building, deploying your application with the changes to that particular vCluster, exposing that as an endpoint so that you get something to test out. So let's say a developer, because you keep on creating features. So as a developer, I did raise a PR, everything works. I get an endpoint to test. I test everything is fine or not. And then boom, I merge it and everything works. So it will be ephemeral pull request environments. That should be interesting to watch.
Caught you off guard real quick. Yeah, so if you enjoyed this, right, like next week, join us. We're gonna have another session. So it's gonna be a session like we had last week. It's gonna be a presentation and then question and answers. So next week we got Salman, and it's gonna be about standardizing dev environments and large-scale multi-tenant Kubernetes clusters. But if you enjoyed this workshop and you want another workshop, like Siam was saying, 2 weeks from today, we're going to see some preview environments, and we're going to take what we learned today and then move it into how do we help developers, write something, push it. There's a preview that comes up and they can test it and see if it's working before they say, hey, this review looks good. So next week, join us for Salman. And then if you want, go ahead and join our community Slack so that you can ask questions, see information about upcoming stuff, and then also we'll post some resources and stuff in there. So join our Slack community. slack.vcluster.com. Go to the vCluster channel. Make sure that you say hello or something in introductions. And then if you have questions, ask them there. But also, if we have questions, you don't have to go there to ask questions. We still have some time right now that we can answer some questions if you have any. So post any questions you have about what you saw today, and then maybe Siam and I can answer it. But yeah, join our Slack enterprise demo if you want to see a demo. After we're done with the multi-tenancy March, we're going to go back and we'll have some weekly demos. So if you want to see how stuff works, you can join us then. And then hand it over to you to say the thank you and stuff, Siam. But I'll also look for some questions to see if we have anything that came up.
Yeah, would love to answer any questions if they are coming. If not, then there is something that I posted today, which is actually multi-tenancy in 2025 and beyond. I just sent that to, I don't know. Okay, sending that to Mike.
Okay.
This particular term, obviously it explains multi-tenancy, it explains about shared platform stack and all that stuff. But in the end, there is very interesting thing I would like everyone to read and give your opinions on internal Kubernetes platforms that are powered by virtual clusters. So IKP is a term, like we have heard about internal developer platforms, but in the end, I think IKP is what people need in the enterprises for deploying their applications, and where Kubernetes is becoming the default base layer where that no one talks about. And then you have vCluster in the centralized piece, and then just everyone kind of getting those virtual clusters. But yeah, I would love to hear, like, just read it, and I would love to hear what everyone else thinks of this and how this will work.
We have a question. So your demo was in the cloud, right? Like, so you're using a cloud provider for the demo?
No. I mean, the Kubernetes cluster is obviously in as a managed Kubernetes cluster. There's no favorable cloud provider. You can pick any AKS, GKE, EKS, or even the tier 2, tier 3 cloud providers, and that should work. So yes, it was a managed Kubernetes that I was already having.
But yeah, so like for your home environment, so the question was from Kirill, talking about like how much memory and stuff like that. So you can do it something pretty small, right? Like there's some cool stuff coming up where you're gonna be able to see it maybe running on like Raspberry Pis and stuff like that. But like for my personal one, I've got a like 72 gig of RAM on a like old DL360, and I'm just running on a couple of virtual machines. And this is just running in like K3S. But you can run it in the cloud, you can run it on-prem. So like if you got K3S or something running locally, you can basically do everything we saw here, except you might have to make some differences for, mapping your IP address into a internal IP address that you can actually get a cert if you want to have it accessible, remotely, or you can just do like a test cert. But how much RAM?
So it basically depends on a lot of factors, to be honest, because the vCluster YAML specification that I showed you, if you are using embedded SQLite, if you want to go to the etcd route or external etcd route, the configuration would change. If you want HA, non-HA, it will change, because it will now, if you do HA, it will spin up 3 replicas of your stateful set, which obviously will take a bit more. But yeah, it's as minimalistic as possible. It's easier to spin up because it's just a container spin up, that much time itself. And if you want to try it online or locally, you can try it on Kind. You can try it on the Killer Coda or IX Labs or whatever the online playgrounds are available. It works over there, and those are, I think, just 2 gigs machines. So means it works with the 2 gigs Kubernetes cluster nodes as well. So it's pretty pretty soft, lightweight, and yeah, but try it out.
I've been watching a ton of home lab videos, so like this is pretty relevant, right? Like, but yeah, I'm running. You can run all this stuff on the home lab, like if you want to split stuff up. So you can do it on the home lab, run it on-prem. Let me see another question. In this multi-tenancy, can one virtual cluster communicate with the other virtual clusters?
So basically, the whole concept of multi-tenancy is we do not want them to communicate with each other, because we want them as isolated clusters. If you want any services, any applications, and whatever stuff like Argo CD, Prometheus, and stuff, those can come as part of the sync which are available. And every virtual cluster can have their own individual sync configurations defined. Like you might want Nginx controller or Cert-Manager synced for one cluster, but you might not want it to be synced for another cluster. So that is something.
The next question is pretty similar. Yeah, for the most part, you're going to have it turned off by default to where they can't talk to each other, but you can set it up so that they can talk to each other. But by default, usually you're going to try to keep it to where they don't understand that they're on a virtual cluster and that there's other people on the same cluster, right? Because the end user, you want them to think that they have a virtual cluster, unless they need to know, right? Like unless they need to know, you can tell them. But yeah, like Sam said, you're sharing that up. You're sharing up the networks. You're sharing up storage, right? Like you're sharing the base storage from the base cluster too. We've got videos on that. Yeah, if you're interested in learning more, head to our YouTube channel. And then you can check out a bunch of like how to. Yes. Yeah, let me link it. Let me link it real quick for you.
So there is something called vCluster Bytes. Specifically, that particular playlist has a very cool demos on how stuff works with vCluster and all the features basically. So external etcd and all those things are already there. So integrations, KubeVirt, everything is kind of there. And would be happy to know if you have any additional use case so that we can create more content around that.
Yeah, and then we have examples too. So Siam and myself have both posted some example files and stuff so that you can go beyond what we've shown today if you want to, test setting up stuff like that storage and everything else. But see if there's any other questions. I know it's getting late there, Siam. Thank you so much for the demo. The demo was awesome. It worked. It worked too without any issues too. So I didn't have to jump in and say anything. I just give you some. All right, I got to give you a round of applause for.
Yeah. The volume for your round of applause is a bit less, so you might want to increase that.
Gotcha. I don't want to overwhelm you. Yeah, but. All right, cool. I don't think we have anything else coming up. So join us Let me go back again. So we end on that. Join
Yeah,
us next
Slack.
week.
And also,
Actually,
feel free to join the Slack. That's the best place to get your answers, questions answered by our experts. And you can also obviously communicate with us anytime on any platform. But the vCluster Slack is something that you should definitely join. It's open source project, so we have a good community out there helping each other in terms of what works, what doesn't work, how to make it work, and all those things.
all right, and I posted the multi-tenancy March link again too. So if you're not signed up for any of these other events, go ahead and sign up for that. We're gonna have a pretty packed March, right? And then right after March, we're gonna be hitting up KubeCon. So I think you're gonna be there, Siam. Everyone come join us at the booth.
Yes, and I'll be there with a session on one large cluster and small cluster best practices. So you should definitely check that out as well. I'll be talking about vCluster and a lot of other things. So it'll be cool. It'll be with my friend Paco. And looking forward to KubeCon. If anyone is coming to KubeCon, feel free to DM us and book meetings. If you want to know more, we have a booth, a lot of cool stuff, which I cannot say now. But yeah, it'll be a lot cool stuff at KubeCon.
Awesome. All right, so I'll leave it with this, and then we'll see y'all next week. And then Simon will be back again 2 weeks from today if you want to see another demo and workshop. So thank you so much for coming, and we'll see you next time. All right.
All right.